Hello, and welcome to the first episode of What I Did, How It's Done, otherwise known as WiDHiD Game Audio. This video series is designed for video game audio designers to understand the audio creation process, including recording and mixing, to using middleware software like Wwise and FMOD, and to importing that audio into game development software like Unity and Unreal Engine. Before we get started, I'd like to briefly go over my background in game audio and what you can hope to get out of these videos. If you're not interested in this and would like to get straight into the action, don't worry. These videos are structured in a way so you can jump to whatever section suits you best. So first thing, background. I have been composing music for over a decade, but perhaps like you, I am still fairly new to the scene of audio development and integration. Unlike most tutorial videos where the experts pass on their information to the rising newcomers of game audio, WiDHiD will demonstrate my journey of doing the research and experimentation of figuring out the mechanics of sound design and audio integration and sharing my experience with all of you. And hopefully following that, I can have discussions with the community to see how we can expand on what we've learned or how we can do it more efficiently. So how am I going to share my experience? Well, first, you get to follow along with video footage from start to finish. Me recording my very first sound all the way to finishing a project in a game development engine. But second, I will also be littering these videos with these little bits of text. If you go to the description of the video, you'll find a link to a Google Doc, which acts as a work cited in an essay. Those little bits of text will reference a single work in that Google Doc. These references are all places I personally checked when researching for this video, and you can go back and check these references in order to expand your learning. I will also be including things that didn't show up in these videos, so you can expand your knowledge even further. And that's it! If you have any questions or concerns at any time during the video, feel free to leave a comment down below, and I will be able to answer you in the best way I possibly can. Or, I can refer you to someone else who will have a much better answer than I would. Without further ado, this is WiDHiD Game Audio.
It's done. WiDHiD Game Audio.
One of the things I would like to accomplish with this video series is to show you guys the source of where all the recording happens. A lot of sound effect design comes from experimentation, going to different locations, using different items, and using a variety of different techniques to ensure you get the sound that you want. There's a lot of planning that goes into this. We need to make sure that we aren't doing the same recording over and over again. So today we are going to walk, run, jump, and land on 5 different terrains to cover all of our bases in our video game project. Let's get started. Now I'm going to take all of the sound effects I recorded and throw them into Pro Tools. I initially recorded them in Audacity for quick ease of access, but you can record and or mix them in whatever sound station you feel most comfortable with. Sound effect creation can have a wide range of complexity and needed creativity, but today's episode is actually very simple. All I have to do is make sure the volume levels are stable and each of the sounds come out crisp, clear, and dry. In this particular project, I used Acon Digital Limit, Acon Digital Equalize 2 to remove any low frequencies, Enhanced EQ by Native Instruments in collaboration with Sawtube to get a crisp and clear sound, and Transient Master by Native Instruments, also to get a crisp and clear sound. I'm going to bounce all of these one at a time. Don't worry about splicing each individual footstep in your DAW. It's more efficient to do it in Wwise. So right before jumping into Wwise, we need to create our Unity project and either find a nice map to work with in the asset store or make one ourselves. I made this one with the Forest Environment Dynamic Nature asset by Nature Manufacture. It has some dirt, grass, some wooden structures, stones, and this bed of standing leaves. Not exactly the most realistic, but it serves our purpose as well. Now let's jump into Wwise. Load up the Wwise launcher and set up a new Wwise project to interact with our new Unity game. I already have mine set up, but you can set up yours by hitting the blue Integrate button and following the instructions from there. Now that I'm in Wwise, I'm going to upload all the sound effects that I've created for this project by dragging the folder they're in to the Actor Mixer hierarchy. I'm going to change the folder so that it's a switch container. You're going to be using those a lot. Next, I'm going to make random containers for all of the terrains that we have here, then drag the audio files into each of their respective random containers. Right now, all of my sound effect files contain several different footsteps. These need to be split up so that every single audio asset only plays one footstep at a time. So open up one of the audio files, we'll start with dirt, and go into the source editor. All I'm going to do is move the squares on the bottom left and right inwards towards the first spike in wavelength, representing our first footstep. You can hit the spacebar multiple times as you do this so you can hear the sound you just spliced, and adjust the beginning and ending accordingly. It's also a good rule of thumb to include a short fade out at the end, which you can do by dragging the triangle at the top of the end section to the left. Now all we have to do is copy and paste this wavelength and move the start and end to the next footstep. We'll rinse and repeat this until we run out of footsteps or until we feel we don't need any more. Then we'll do the same thing for the other 4 terrains. This will take a bit, especially if you have a lot of terrain to work with. After all of that is done, I'm just going to take a moment to listen to all of my sounds. If I select the random container and hit the spacebar multiple times, it'll cycle randomly through each of the sounds in the container. From here, you can make a decision on if they all sound right to you or if they need to be changed or removed. If some of the sounds need to be changed, you can change them in each of their individual sound files. But if you want to change all of your sounds, you can edit them through the random container. The main ones you'll be focusing on are volume, high pass filter, low pass filter, and pitch, which you can set positive or negative values. You can even randomize these values by double-clicking the circle directly to the left of the number values and setting the minimum and maximum change. If that circle is yellow, it means the randomization is active. Right now, I'm just going to change the volume of each sound file so that they are all at consistent levels. Then, I'm going to change each of the other 3 values as I deem necessary. Also, in each of the random containers, I'm going to change the play type. Standard play type is truly randomized based on each of the sound files' priority rating. However, you can ensure that the same audio file does not repeat twice in a row by setting the Avoid Repeating Last to 1 or more. Shuffle play type is still randomized, but ensures that all sound effects are played at least once before cycling through each sound effect again. Great! We now have most of our sound effects prepared for the rest of the tutorial. The rest of this section is simple. Head over to the Game Syncs tab, make a new switch group, and name it whatever you like. Footsteps should do for now. Then, under that group, make switches for each of the terrains that we just made containers for. Now go back to the Audio tab, select the Footsteps switch container that contains all of our audio, and go over to the switch group on the far right side. Set it to the new Footsteps switch group that we just made, and set the default value to dirt since our character is going to start on the dirt when they load into the world. Then below that, we're going to take all of our random containers and drag them to their respective switches on the right. We're almost there for this first part. Head over to the Event tab and make a new event. we're going to drag our footsteps switch container into the event area that we just created, and it'll make a new event to play the footsteps switch container. That's exactly what we want. And that's it. All we need to do now is put all of this into a sound bank, which will be shipped off to Unity with all of the information that we just provided. Go to the sound bank manager or hit F7 and make a new sound bank in the default work unit. Name it whatever you like. Then we will drag the event that we just made into the sound bank. Before we generate the sound bank, select the platform that you're going to use and the language. I'm on Windows, so I will select Windows and English. Then I'll select Generate Selected. That's it for part 1. We now have the ability to tell Unity to play a certain set of footsteps whenever we switch between each terrain type. However, our character won't just be walking. They'll be running and jumping as well. So we now need to make a container for each of these locomotion types. First, I'm going to import 8 different sound files, dirt and grass for when the character is walking, running, jumping, or landing. Then we are going to make switch containers for each of the 4 locomotion types. Next, just like we did in the last section, we're going to make random containers for both dirt and grass in all 4 locomotion switch containers, and drag in the audio files into their correct containers. Last, we're going to place all of the locomotion switch containers into a parent switch container. Now you can splice your audio files in the exact same way we did in part 1. Since you've already seen this, we'll jump ahead. That was a lot, and this was only for 2 terrains and 4 locomotion types. Large games will have far more of each, so it's important to make sure all of this remains organized for both you and your team. Now, we're going to head over to the game sinks and make a new switch group. This switch group is going to contain the switches for all of our locomotion types, so add a switch for walking, running, jumping, and landing. Go back to the Audio tab and go to each of your locomotion switch containers. In this, set the footsteps switch group that we made in part 1 and set the default to dirt. Just like before, drag each of the random containers into their respective switches. In this instance, don't worry about leaving rocks, wood, and leaves empty. Now move on to the mother switch container, which contains all of the locomotion switch containers. Set this to the new switch group we just made, and set the default to walking. Drag each of the locomotion switch containers into their respective switches. And now all we have to do is make sure that Unity can play this mother switch container. Go to the Event tab and make a new event. Drag in the switch container that we just made into this event, and leave it as the default play event. Now hit F7 again, let's go to the Sound Bank Manager, drag in our new event and generate the sound bank. We have now added locomotion types to our 2 terrains, dirt and grass. With the last 2 methods, anytime you would go on a new terrain and set the switch, there is an abrupt change in audio files. One footstep is on all dirt, and another footstep is then on all wood. However, there is a method of being able to blend the 2 together if you're gradually going into a new terrain. In this case, what if we were going into a bed of leaves that gradually got thicker as you walked into the center of it? We can do that by using RTPCs, or real-time parameter controls, and blend containers. So first, we're going to jump into Game Sinks, and now we're going to head over to Game Parameter. This is where we're going to make our RTPC. Make a new game parameter. I'm going to call mine Leaf Stepping. In this new game parameter, we can set our minimum and maximum values, which is going to be entirely dependent on what values we put into Unity. I already have a good understanding of my minimum and maximum values, but chances are you'll need to adjust these values later when you get more information from your game project. Now I'm going to head back to the Audio tab and make a new blend container. We could import new sounds for this section, but we already have sounds utilized in previous sections that we can use for this section as well. So I'm going to take the dirt random container and the leaves random container from part 1 and copy paste them into our new blend container. Let's use our blend container. Go into the contents editor of our blend container and hit the edit blend track button. You can name it whatever you like, then hit the crossfade button, adding our new leaf stepping game parameter. Add our leaves and dirt switch containers into our blend track in that order. Order does matter here. Right now, we have leaves and dirt perfectly split down the middle. If the RTPC value is half the maximum value or less, it'll play the leaf sound. If it's half or more, it'll play the dirt sound. We don't want the sudden change, we want it to blend. Drag the dirt sound all the way to the left so that it completely blends into the leaves. Then drag the leaf sound 3/4 of the way to the right. I'll briefly explain what this diagram is now signifying. The values we put in represent how far we are from the center of the bed of leaves. If we are 0 units from the center, then we will only hear leaf sounds. If we are 3 to 4 units from the center, then we will hear some mixture of both leaves and dirt. As we get further from the center, then the leaves audio will slowly drop to 0 until we are only hearing dirt. You can hear this by dragging the RTPC meter on top of the diagram left and right, and pressing the spacebar to hear how each sound is blending together. You can make any edits as you need to, but just like in the last 2 sections, all you need to do is make an event to make the blend container play, and add that event into the main sound bank. And with that, we have completed the Wwise side of things. Let's jump over to Unity. Back in Unity, we need to do 2 major things before we move on with our project. First, we need to ensure that Wwise integrated with Unity properly. If it hasn't, try refreshing Unity or going back to the Wwise launcher to see if the Wwise Unity integration occurred properly. If it has, then head over to the Wwise Picker tab and hit the Generate Sound Banks button to ensure that the files show up in your Wwise assets. If they aren't, make sure that you saved your Wwise project, otherwise the assets won't transmit properly. Now with access to our Wwise assets, go to the new Wwise Global object and add AK Sound Bank to it. Set the sound bank to the main sound bank and set for it to start on awake. In a larger project, you'll have other methods of running your sound bank in-game, since you will likely have different sound banks for different areas of your game. But since we only have one, we'll simply generate the sound bank right when the game starts. Next, and most importantly, we need a character that we can use to make footsteps for us. For this, we are going to go into the Assets store, search for the Unity Standard Assets, and download it. When asked to import the assets, you will not need all of the assets listed. In the Standard Assets section, only include characters, cross-platform input, and utility. Let that import into your project. This asset pack was designed in 2018, so if you are on a newer version of Unity, you will come across 1 or 2 errors. The error in the forced reset script can be rectified by adding on line 5 using Unity engine.ui and replacing GUI texture in line 7 with image. The error in simple activator menu is very similar. In line 3, add using Unity engine.ui and replace GUI text in line 11 with text. Last thing with the standard assets, then we can move on. Go into the standard assets folder, then the characters folder. You're going to take the first person character folder and drag it into the main assets folder. This is so Wwise can effectively communicate with the prefab found in this folder. Go into the first person character folder, then the prefab folder, and drag the FPS controller into your project. Now, when this character walks, we needed to know to play a sound from our Wwise sound bank with each of its steps. Right now, the character is looking for audio from a Unity audio source, which was disabled when we integrated Wwise. So we need to change the script to make it work with Wwise. In the FPS controller prefab, go into the first person controller script and scroll down to the section Play Footstep Audio. This part of the script checks to see if the player is on the ground, and if they are, play the footstep audio. So everything from the comment that states pick and play a random footstep sound from the array and the final reference and footstep sounds can be deleted because this is all calling the Unity audio source, which is disabled. We're going to add in our own script, aksoundengine.postEvent part1 game object. This is basically just posting our footsteps event, which if you recall, we set to play our footsteps switch container. And we're setting the event to play on the game object this script is attached to, which is us, the player. But now we need the player to know what terrain they are on, which we do by setting a switch anytime the player walks on a new terrain. For this part, we are going to set our switches using a bunch of box colliders, and we are going to do it for our sections of grass and dirt. So first, make a new cube object. In the box collider script, check the isTrigger checkbox. Now add an AK switch script. Change the trigger on to AK trigger enter, then check the use other object checkbox. Then we need to set a switch for this particular box collider. We're going to start with all of these patches of grass, so set the switch to grass. Basically what happens is, whenever a player steps into this box, Wwise will set the switch to grass. And when the character controller plays the footsteps event, it will know to switch to the grass random container and play the audio from that. Now for the tedious part. We need to stretch this cube over all of our grass. Set the cube somewhere on the grass and adjust its size to best fit that portion of grass without crossing into any of the other terrains. You might want to get good at switching between the Move tool and the Scale tool with the W and R keys, because you'll be switching a lot. Once you've done that, copy-paste another cube into your project and drag it into the next section of grass. Rinse and repeat this until all of your grass is covered. Don't worry that there's a bunch of white blocks now on your map. We'll be getting rid of those in a little bit. With the grass done, we can select all of our new cube objects and disable the mesh renderer. Now we can't see the colliders in game. Now do the exact same process with all of the dirt in the scene. And that's all there is to it. If you go into your scene, you'll start on the dirt and hear the sounds of dirt. Then go onto the grass and you'll hear the sounds of grass. If it doesn't work, then check your collider trigger settings or the placement of your colliders. If your collider does not properly hit your player collider, then it will not change your switch. Hey guys, Future Character Composer here. Before we move on to the test demo, I completely forgot to include how I scripted in the jumping and landing sounds. In Play Footstep Audio, add in aksoundengine.setState, Locomotion, Walking, Game Object before our post event. Then copy both lines of code. Paste them in the Play Jump Sound function in place of the 2M audio source line, and replace walking with jumping. Then paste them in the Play Land Sound function as well, replacing walking with landing. Alright, back to present me. Now we're going to use the RTPC that we made in the third part of Wwise. Earlier, we made an RTPC and blend container for our dirt and leaves, so that we can gradually go from the dirt sounds to the leaf sounds as we walk to the center of our bed of leaves. Now we can integrate it into Wwise with one simple script. First, we're going to make a collider for our leaves. In this case, I'm going to use a cylinder instead of a cube. Just like before, disable the mesh renderer so we can't see the actual shape and check the isTrigger checkbox in the collider. Next, we're going to make a new script, which I'm going to call player distance. I'm going to remove the void start and void update, and I'm going to utilize the onTriggerStay function. Basically, anytime you remain inside of this trigger, this function will continue to be called until you leave it. Inside of our new function, we'll make a new float, which I call dist. and this float will be calculating the distance between the position of another object, which is us, and the position of the center of the leaves. Before we set our RTPC to this value, remember when we only set a generic minimum and maximum for our RTPC in Wwise? This is our chance to figure out what values to actually place in there. Use the script print dist and go into your Unity project and walk to the very edge of the bed of leaves. The very first printed value in your console should be the number that you place as your maximum. And in theory, your minimum value should be 0 in this case, as long as it's actually possible for the player to go through the actual center of your collider. Now that we've figured out our RTPC maximum value, you can delete the print function as it no longer serves our needs. In its place, we're going to set our leaf stepping RTPC value to the variable dist. Last thing, I'm going to go back into my first-person controller script and change my post-event script so that it's posting the part 3 event instead of the part 1 event. Now we can test it out. And that's it for this video. Remember, if there are some concepts that you didn't quite understand, there is a link to a Google Doc in the description, which will reference you to all the things I used in this video. Also, this Google Doc will contain things that were not in this video, so you can expand your knowledge further. If you have any questions, comments, or concerns, feel free to make a comment below, or send me a tweet. My tweet handle is @KaraComposer. This video series is made more successful if the community partakes in it, and I welcome any constructive criticism about what I did right and what still needs improvement. It is also helpful to know what you all would like to see in future videos, like what kind of sound design you would like to see, or if you'd like me to use other software like FMOD or Unreal Engine. But until then, I'll see you all in a couple of weeks for the next video.